Hello and welcome to the final series of mathematical logic. So today we're really going to get into what a mathematical proof is, how all that stuff we learned all ties together in math. So when you think about a mathematical proof, it's a lot like the story if you give a mouse a cookie. If we set a statement or set up our if-then statements so that they follow progressively, we kind of get a connecting true story. If you study, then you understand math better. If you understand math better, connecting one statement to the other, then you get better grades on tests. If you get better grades on tests, then you get better grades in the class. If you get better grades in the class, then you get into a better college. So if we were to logic through each of these statements, we would know that therefore, if you study, then you'll get into a better college. Math proofs work this exact same way. They're connecting truths that we know together so that you get at a final answer. You start with what you know and you go to where you want to be. So let's think of this a little bit mathematically. So if I take this simple statement, if x plus 4 is 2, which we're just assuming is true, remember we always assume that first if, then x plus 4 minus 4 equals 2 minus 4. Remember, we can always minus 4 on both sides. So if this is true, then x equals negative 2. So then we have the conclusion that if x plus 4 equals 2, then x equals negative 2. So since we assume this is true, we know this is true. Now let's try that with something a little bit more complicated. If 3x minus 5 equals 6, then we can add 5 to both sides. Now, since we added the 5 to both sides, we can compute it out and know that 3x equals 11. So I know that this is the same as this. And if 3x equals 11, well, then I can divide both sides by 3. Since I've divided both sides by 3, I know x equals 11/3. So I can pull these things all the way together by saying, if 3x minus 5 equals 6, then x equals 11/3. This is a lot more how the mathematical proof's going to going. But this has a lot of ifs and thens, and we're repeating ourselves a lot. And like we said in the first video, mathematicians are simple. So we created a column proof. It's set up and the logic works exactly the same way. But what we're doing is we're taking that problem that we're going to work on and we separate out the steps and the reasoning. Because our last proof was nice, but we don't know why we're able to do each of these things. We haven't proven that this is true here. We didn't tell them why. In our in our column proof, two-column proof, we'll be able to say the why. So we'll do our steps and then our whys, just like our if-then statements. So if I had this problem, 12x minus 9 equals 2x, well, I know that I can subtract that 2x from both sides. Now, in math, we need to prove it, so you really have to say the why. So this is like if this, then this, because of this. This is like the last little step. So I can subtract 2x from both sides because of the subtraction property of equality. Now, once I do that, I'm going to want to simplify it. Well, that's called simplification or arithmetic or simplified. And then that gives me 10x minus 9 equals 0, just simplifying. Then I move on to the next step. I add that 9 to both sides. And I know I can do that because the addition property of equality. I'm going to simplify again. And finally, I'm going to divide out that 10 because I know I can do it from the division property of equality. And that gives me my answer through simplification. So the steps work exactly the same. But what makes the transition from if this, then this, because of this. If this, then this, because of this. If this, then this, because of this. That's how it works. If this, then this, because of this. And this is a great part of what we do in math. We prove that if this is true, this has to be true because of all this and this. Okay, I'm going to have you try one of these on your own, and then enjoy the rest of your day.